Hello students, so in our last lecture we talked about linear regression, and it is given in the lecture number 250 and 251. Now in these linear regression we expressed that y or any of the variables can be expressed in terms of the other variables in the following manner: a1x plus a0, or it can be the other way around. X can be expressed in terms of y, b1y plus b0, and we also did some example. Now what we will do here, we will find the algorithm. We will try to understand the algorithm in finding out these coefficients. So let's say we would like to find out the values of a0 and a1. So what is the algorithm that we will use? First, let's write the formula once again. So a0 is so both of them are having the same denominator. So for both of these cases, the denominator is n summation x square minus summation of x whole square, and that is the same with this one also, square minus summation x whole square. The denominator, on the other hand, for the case of a0 is summation y summation x square minus summation x into summation xy, whereas in case of a1 it's n into summation xy minus summation x into summation y. Now how to write the algorithm? So first we need to reach n, then we need to keep on doing it. We need to feed the different values, and lastly we need to find y, we need to find x, then x square, y square, and we need to sum. Keep with the value of I is equal to 1 to n. We need to find the value of summation of y, summation of x, summation x square, and summation xy. Then put them in the formula at the last. Let's see how we can do it. So first step is you need to read n. Then second, you need to define a quantity sum x, and need to feed it the value 0. Then we need to define sum x squared So for x square, since we cannot write x square, so we will write x s q. It means x square, and it also has the value 0. Then we need to find out the value of sum of y, feed it with the value 0. Another one is xy. So sum xy, also it is 0. So all the summations have been defined. Now second is we need to start the summation, that is for I is equal to 1 to n. We need to start a do loop. A do loop has to be started, and inside the do loop we'll read xy, read x and y, then sum x is equal to sum of x plus x, sum x square it will be sum sx square plus ss square, sum y plus, that means all the values are being added by the next corresponding value for the next I, and lastly sum xy is equal to sum xy plus xy. So this will go for the do loop, and then and for, so this will all come under the do loop. After that you need to write it for the denominator, so let's omit this one. So let's assume that the do loop has been completed here, and for, then the seventh step is denominator. Denominator is fitted with n into sum xs cube minus sum of x into sum of x, that will go for denominator, and each step would be a0, which will be equal to sum of x into sum of xs cube minus sum of x into sum of x, and divided by denominator that we have initially assigned, and the same will also go for the ninth step. That is a1 will be again equal to n into sum of xy minus sum of x into sum of y divided by denominator. So we have found out the values of a0 and a1. The 10th step will be write a0 and a1, and then last one will be stop. So this is how the algorithm is written. Now this algorithm is pretty straightforward. The variable n gives the total pair of values of x and y, and in the for loop we require the sums are accumulated. The above algorithm leads to its numerical difficulties and loss of significant digits, Suppose if xi, the sums xis and yis is large and closely clustered, in such a case we take difference of two large almost equal numbers, which is numerically bad. For large numbers it is numerically bad because the difference will give you the very large values. So we need to find out a better formula which retains almost equal numbers and which retains significant digits and is to subtract out the mean value of the variable and rewrite the formula. So we need to do some algebraic manipulation for that.
मैं हिमांक की मम्मी हूँ और जब हिमांक हुआ था हिमांक को सांस में लेने में प्रॉब्लम थी, इसके गले में भी छेद है और दिल में भी.
So we need to do some algebraic manipulation. We can show that n, which is summation of x minus m whole square, it is equal to n into summation of x square minus summation x whole square, where this m is nothing but the average value, that is 1 by n summation x. This is how we can show it. And also we can also write n into summation y x minus m. This is equal to n summation xy minus summation x into summation y. And lastly we can also write summation y into summation xi minus m whole square minus summation x into summation y into xi, summation, we're not using any I here, so to make it simple, this will be simply equal to summation y, summation x square minus summation x into summation xy. So by introducing this mean term or this average term, we have modified these equations a little bit. So if you put all these values, the denominator and the numerator values for both x and y, we'll end up with the following relation. For a0, the expression changes to summation y into summation x minus m whole square minus summation x into summation y x minus m divided by the denominator n into summation x minus m whole square. And a1 now becomes summation y into x minus m divided by the denominator summation, the ends cancels out, into summation x minus m whole square. So these equations or these relationship They do not involve taking the difference of large quantities. Do not involve taking the difference of large quantities, and so they are numerically better than the previous one. So similar to the algorithm that we have written for A0 and A1, we can also write the algorithm for A0 and A1 using this mean value theorem. So the only difference is that in the algorithm, the only addition that we will we have to find the value of m. The mean m has to be found out first in the algorithm and used later to evaluate the other sums. So one of the disadvantage or one of the requirements for this is that it requires more storage. So more storage is required, storage space, and also more time is required. But ultimate advantage is that it is numerically better than the previous case.